Okay, so today we're going to deal with matrix equations. And the idea behind matrix equations is kind of what we have on the bottom here. So let's say we have some matrix A times some matrix X that we don't know what it is. And we want to equals some matrix B. And we want to find matrix A. Generally, if this was a normal problem, you would divide both sides by A to figure out what X is. But the unfortunate part is matrices don't have division. They do have inverses. So if we put the inverse of matrix A right here, and you do matrix A inverse times matrix A, these two things will end up canceling. And then we would just have to multiply it on the other side. You do have to be very careful about how you multiply it, because if you multiply it in the front here, you have to multiply it in the front here. Or if you multiplied behind A here, you'd have to multiply behind B here, because matrices aren't commutative. For us, most times it's going to make more sense just to multiply it right there in the front. So we're going to try the problem below and try to do the same thing. So the first thing we would need to do is get the inverse of this matrix right here. Well, if we remember from yesterday, to find the inverse, we first have to find the determinant of the matrix, which we multiply the major diagonal over the minor diagonal. So that would be 12 minus 5, which would give us 7. And then we put in the inverted matrix. So to invert this, we get 6, 2, -1, and -5. Now, when we take these two things and times them, which I'm not going to do because it will take too much time, they will cancel. And what we mean by cancel is we will get the identity matrix, which is a matrix 1, 0, 0, 1. So those things will cancel. Now we just have to times our inverse on the other side. So we'll have 1 over 7, 6, -1, -5, and 2. And we will just times these two matrices. So again, if you remember how to multiply matrices, you go row by column. So we know that X will equal, so I'm going to keep my 1/7 in front. That would be 18 minus 4. And then we'll multiply the next row by this column. And we will get -15 plus 2. Then if we wanted to simplify this down to being as simple as possible, we would say that this equals 1/7 14 over -13. And we could even simplify this further and say, well, this is really 2 over 13 over 7. So I know that took a little bit, but hopefully that kind of makes sense. So there is no division. So we will multiply both sides by the inverse matrix. So all you have to do is find this inverse matrix over here. Multiply it on both sides. The front side will cancel out, so you don't have to worry about it. The back side, when you multiply it, will end up giving you your final answer. Let's look at a couple more. Okay, so in this second example, again, we want to times the inverse on both sides so that we can cancel this. Again, we want to do the major diagonal versus minus the minor diagonal, so that would be equals 10 minus, oh, that's going to be 0. So we have a 1/10. 5 would go up here, 2 would go down there, 0 can't be negative, that would become a positive. And now we'd need to multiply this on the other side. I did not give myself enough space, so I'm going to erase that 2, 4 and give myself some more space. So then we will put the matrix in here, so 1/10. and then 2, 0, negative 1, 5. Again, we will multiply these axes, so I'll have 1/10. So x is equal to 1/10. That'd be 2 plus 0, that'd be 4 plus 0. And then we'll multiply the other one, which that would be negative 2 plus 20. So again, this would simplify to be 4 over 18. And then if you really wanted to, you could have your final answer be 4 over 10 and 18 over 10. I don't care about simplifying. If MathSpace really wants you to simplify these fractions, you really could have it as 2/5 and 9 over 5. But again, that would be good enough. Even this would be good enough for me if you don't divide everything by 10. Let's do one more. Okay, so let's take the classic matrix 1, 2, 3, 4 and times it by 1, 2, 3, 4 on the other side. So again, to undo this, to figure out what x is, we would have to multiply this side and this side by the inverse. If we take the determinant of this, this will be 4 minus 6, which gives us negative 2. Whoops, I meant to be 2. We would flip 4 up here, 1 down here. Negative 2, negative 3. Again, these matrices would cancel. I would do that on this side. We're going to have x equals, and now we will multiply. Go row by column. You stick the negative half out in front. We should get 4 minus 6, this first bubble. I'll have to go row by column again. For this one, we should get 8 minus 8. And then we're going to go row by column again. And I should get negative 3 plus 3. And then we'll go row by column one more time. And I should get negative 6 plus 4. And that is negative 1/2. And this would become negative 2, 0, 0, negative 2. And if you simplify that down, you get 1, 0, 0, 1, which is the identity. Which, if you look up here, makes sense because we have A, that's matrix A, x equals, oh look, that matrix on the other side was exactly the same, equals A. So before, if you would do this by just dividing, you'd have x equals 1 because anything divided by itself is the same thing. And matrices, our one matrix is this right here. So if you ever get a case where you have the same matrix equaling the same matrix, you know that it's the identity. That's got to be x. Because you want to multiply this thing by 1, and that's how we say 1 for matrices. That's really what's happening when we multiply these sides, because you could see that it would be like literally we're multiplying the same thing as on both sides. That's what happens. That's why this thing cancels. It becomes the one matrix. If you have any questions on this, let me know.